Hi guys, welcome back to my channel. So today we'll learn all about Numpy. So Numpy is a very interesting library. It is mostly used in data science because of its speed. So Numpy allows you to do a lot of mathematical operations and it is quite fast since it has all these C bindings. The famous library pandas is also written over numpys. So if you want to know more about numpy documentation, you can just hit numpy and go to their official website. So there you have everything about getting started, installing the packages and things like that. So installing numpy is very simple. Here I've opened a Jupyter notebook. So I'll just type the command. So you can do a pip install numpy, or I'd prefer conda install numpy. All right. So I have already installed numpy. So what I'll do is I'll import numpy. The convention of importing numpy is import numpy as np. Shift enter. So numpy is imported over here. Shift enter again. You can see that the numpy is been imported from this particular package. Let's begin with arrays in numpy. Numpy has this array where you can pass 1 2 3 4. So basically your list, that is 1 2 3 4, has been converted into a numpy array. It is much similar to the list, but the computations are quite fast. Let's save this array into an object or into a variable arr. So array 1 2 3 4. So if you want to know the shape of the array dot shape 4 0, because it is a one-dimensional array. And now you can reshape the array into a two-dimensional. Let's say we want to convert it into a matrix, a 2 cross 2 matrix. Okay, I didn't enter reshape. So here you have a matrix of 2 cross 2. Now accessing an array is quite simple. Now the array is still in one dimension since I have not given this reshape back to the array. So if I had to save this particular reshape, I had to assign it to the variable arr. So now accessing the array is indexing is quite similar to Python. Index starts with 0 and shift enter is going to give you the first element. So are these arrays mutable? Let's see that. Of 0 equals, let's put 6. Yeah, in fact they are mutable. Now if you want to see the entire array, just type the array. So 1 is replaced by 6. So arrays are mutable. You can also try out the different functions that are associated with this array. So arr.dtype will give you the data type of this array. Also there are many other functions like sum, the total sum, or you can do like the mathematical operation. Let me show you. Array plus, if you want to add two arrays, it is a element wise addition. Since array was 6, so 6 plus 6 is 2al, 2 plus 2 is 4, 3 plus 3 is 6, and 4. Also multiplication, like into, let's say into 3 times, so it is element wise multiplication. Now let's say you want to divide it by 3, element wise division. Also there is a cool function like range. So instead of using range, we can use a function called arange, np.arange. So 1 comma 10 will return to you an array of 1 to 10, and similar to your Python or Python inbuilt range, you can also pass the step size over here likewise. So once that is done, and all this division, multiplication, also the exponential with the 2 stars, you can do that. Let's say you want to do you want to create a matrix out of it. Dot like I said, reshape a 2 cross 2 matrix. Now how do you access this matrix? Array of it's similar, it's row comma column separated by this thing. So colon will give you all the rows and columns. So let's say you want just the first row. It's 0 based index, so here you have the first row, and let's say you want just the first column, so you could do this. Also you can access the different, like sum. This will sum up all the elements of the array. Let's say you want to sum up just the row. Access is equal to 0, row will be 1, and as you can see, ARR, so 6 plus 2 is 8, 3 plus 4 is 7, and if you change it to 0, it's going to do a column wise sum. So there are many inbuilt functions that you can use. For example, let me pick one of them. I have already used some of them, like sum, max, mean, minimum. Also, let's check the mean of this. So it's 3.5. If you want a standard deviation of it, you have it. So there are other things, other functions that I want to show you. Oh, okay. Let's try with the okay, which one do you want? You can sort. Okay, it's sorted. It doesn't return anything, but you can see that they are sorted row wise. And if you want to look at help, you can always look at help np.sort, and there you have a lot of help over here, like the access that you can pass, the kind, like quick sort or merge sort or heap sort. This is a completely robust library that you can use, and it is very fast in computations, so you do not have to worry about speed. Also you can do indexing. Let me show you some other, like a range. You want to create zeros, array of 10 zeros. Let's say you want to reshape them into a 2 cross 5 matrix. Reshape 2,5. Also there are functions like you can create ones. Let's say you want 10 ones. Also you can create zeros, ones, and the identity matrix, which is basically a square matrix with the diagonal elements as 1. So you have this, and let me show you one more function called line space. What this does is, it is similar to range, but don't get confused with range. What this will do is split your given numbers. So this is the range, split them into, let's say, 5 equal parts. So you have the number 1 to 10 split into 5 equal parts. So there are many cool functions like this. So I guess I have covered quite a lot about the basics of arrays and matrix. So array is basically a data type, so it can be used in one dimension, which can be called as a vector, or a two-dimensional, which is a matrix. And you can perform all these operations like addition, subtraction, division, multiplication, square root. Also you can find mean, standard deviation, sort the arrays, and creates the array of zeros, ones. Let's say you want to create an array of all the elements of 100, so just multiply it with 100. Let me see if there is anything else that I can show you. So here you have an array, right? Okay, let me create a new array. range, not range, a range from 1 to 10. You have to mention np because it's from the numpy array module. Print this 1 to 10. Now if you want to slice an array till the third element or the fourth element, and you want to save like 100 into it, so this is called broadcasting. Basically you are storing the you have sliced this value and stored into 100. Also if you have a is equal to array of we have done 100, right? So let me take the same value. Now your a will have an array of all the hundreds. Now you want to store it 200s. Now let's print out what okay, this is not good because I forgot to slice it. So let me store 200, and now if you print the arrays, instead of 100 you have 200 because the slice that you did over here, basically this has stored the pointer to this location and not the actual values. If you want to store the actual values, what you have to do is you have to do a copy. So I'm guessing it's numpy.copy. So everything is 200. Let me change it to 400 so that you can see the difference. You can see that now this original array is not updated because you have created a copy. You can also check that using the id command, which returns the location. Obviously now the two locations are different. If I had not used this copy over here, it should have been the same. Okay, I probably have to give the slice id of the slice and this id of up till 4. Did we change anything? I need to look into it, so I do not want to waste the time here. Let's move on. I'll quickly check if I have missed anything that I had to say. argmax. Okay, so array.max is going to give you a maximum value, and now if you want to get the just the index of that maximum value, so you will get this index. So this maximum particular, this 400 is at the index location of 0, and indexing I have been through it. So this is pretty much what I wanted to cover here. Also I want to show you something. I'll create a new array with np.arange from 0 to 10. Now this new array, if I have to divide the array with 0, normally 0 by 0 would have thrown an exception in Python like this, 0 division error. But in NumPy what this does is it's not going to throw an exception. Instead it's going to throw you a warning, and your values are basically going to infinity because it's divided by 0, and this is nan because it is a 0 by 0 division. So just keep that in mind. You may be expecting it to throw a 0 division error, but which is not going to do it, and you should be good. In the next session I'll be talking about pandas and the things that you can do with pandas. All right, So thank you for watching. Have a good time. Bye bye.